Students, good morning, students. So myself, Dr. Eustace Russell, working as assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So in the previous video lectures, we have covered two important topics, two important units also, gear and gear trains. As well as first unit, the kinematics inversions, cam profile, circular cam, and various concepts we have discussed in the first two units. Now we are shift on to the next unit that is important unit, that is called friction. Friction is a very important one. Every day-to-day life we are experience of that wear and tear, how it is occurring, everything. Now we will have a study on that also in mechanical components. So this slide represents the syllabus of unit 3, sliding and rolling friction angle, friction in threads, friction drives, belt and rope drives. So these are the important concepts, and it's a very limited syllabus in unit 3. So we have the 4 parts in this unit also. So today the introduction session will be done in friction and continued by formulas and problems. Discussion session also will be there. We will see one by one. First important topic, friction in machine elements. So why in machine elements the friction is most we have to consider. Friction is a measure of how hard it is to slide one object over other. So this is meant by friction. So how it is very difficult to slide over another object means then friction is there. First of all, it is static friction. It is a friction experienced by a body when at rest. So that is in static motion, without any motion. It is with it at rest should be considered that. Dynamic friction. It is a friction experienced by a body when in motion. So what is the difference between dynamics, static and dynamic means? That is under body and rest, which is under motion, we have to consider that. Dynamic friction is also called as kinetic friction and is less than the static friction. So it is of two following three types. Sliding friction. It is a friction experienced by a body when it slides over another body. So it is nothing but sliding over another body. Rolling friction. It is a friction experienced between the surfaces which have balls or rollers imposed between them. That is bearings. Most examples we will be having that. Pivot friction. It is a friction experienced by a body due to the motion of rotation, as in case of footstep bearings. So this is a motion of rotation. Pivot friction, that is that. Footstep bearings, that is the consider the motion of rotation. So again it will be classified into two important things. Friction between unlubricated surfaces, friction between lubricated surfaces. The friction can occur in both conditions, whether it is unlubricated state or lubricated state. Then laws of static friction. Force of friction always act in a direction opposite to that in which the body tends to move. That is important. The force of friction always act in a direction opposite to that in which the body tends to move. The magnitude of the force of friction is exactly equal to the force which tends the body to rotate. That is important. It tends the body to rotate or move, whatever it may be. Then magnitude of the limiting friction be as a constant ratio to the normal reaction between the two surfaces mathematically. That is F by R equal to constant value. Force of friction is independent of the area of contact. That is whether the area of contact, that is very, very important. Where is the which is area of the contact which is independent of that two surfaces. Force of friction depend upon this roughness of the surfaces. Then this slide represents the coefficient of friction, very important definition. It is a ratio of limiting friction to the normal reaction between the two bodies. It is generally denoted by the term mu. The coefficient of friction mu equal to F by Rn. Consider a body A of weight W is resting on a horizontal plane B as shown in figure. If horizontal force F is applied to the body, no relative motion will take place until the applied force P is equal to the force of friction F, acting opposite to the direction of motion. The magnitude of this is given by F equal to mu W equal to mu R. N is the normal reaction and in limiting case, when motion just begins, the body will be in equilibrium under the action of three forces. What are the three forces means? Weight of the body, applied horizontal force, reaction R between the body A and the plane A. Reaction R must there be equal and opposite to the resultant of W and P and will be inclined at an angle to the normal reaction Rn. The angle is known as limiting angle of friction. Limiting angle of friction. It is defined as the angle which the resultant reaction R makes the normal reaction Rn. That is tan phi equal to F by R. Angle of repose. Consider that the body A of weight W is resting on an inclined plane. If angle of inclination of the plane to the horizontal is such that the body begins to move. So whenever the body begins to move, that tends to move, that is called repose. That is impends. It start to get moved. So that angle alpha will be considered as angle of repose. So screw friction. Screws, bolt, stud, nuts are widely used in various machines and structures for temporary fastenings. These fastenings have screw threads which are made up by cutting a continuous helical groove on the cylindrical surface. If the thread are cut on the outer surface of the solid rod, these are known as external threads. But if the threads are cut in the internal surface of the hollow rod, these are known as internal threads. Screw threads are mainly of two types, V-thread and square thread. V-thread are stronger and offer more frictional resistance to motion than square threads. So V having a more frictional resistance, that is important, than square thread. V-thread have an advantage of preventing the nut from slackening. In general, V-threads are used for the purpose of tightening the pieces together. Then following important terms that is mentioned over here. Helix. It is a curve traced by a particle while describing a circular path at a uniform speed and advancing in an axial direction at a uniform rate. Then pitch is the distance from the point of screw to the corresponding point on the next thread. That is called pitch, the distance between the two consecutive threads. Lead is the distance a screw thread advances axially in one turn. Depth of thread. It is the distance between the top and bottom surfaces of the thread known as crest and the root of the thread. Single threaded screw. If the length of the screw is equal to the pitch, is known as single threaded screw. Multi-threaded screw. If more than one thread is cut in one lead distance of a screw, is known as multi-thread screw. That is example is double-threaded screw. Two threads are cut in one lead length. In such a cases, all the thread run independently along the length of the rod. That is lead equal to pitch into number of threads. Then helix angle is a formula we are using. Tan alpha is equal to lead of the screw divided by circumference of the screw. So here starts with one basic problem. Electrical motor driven power screw moves a nut in a horizontal plane against a force of 75 kilonewton at a speed of 300 mm per minute. Screw has a single square thread of 6 mm pitch on the major diameter of 40 mm. Coefficient of friction at this screw thread is 0.1, estimated power of the motor. These are the given conditions. We have to take the given condition first of all. The W it is given, V is given, P is given, DO is given, that is major diameter. Mu, coefficient of friction, should be taken as 0.1, it is given in the problem. Then we have the basic formula, mean diameter of the screw is nothing but D equal to D naught minus P by 2. You are getting 0.037 meter. Then using helix angle formula, tan alpha, we are using P by pi D. On substituting, we will get 0.0516. Then for force required at the circumference of the screw, this important formula, how much force we are applying to lift the screw threads. This is a basic formula, P equal to W tan alpha plus pi. We have to use the formula tan alpha plus pi. In the trigonometry, we will get tan alpha plus tan pi by 1 minus tan alpha tan pi. On substituting the values, you will get 11.43 into 10 to the power 3 Newton. Then again T equal to P into D by 2, that is torque required. Then using that, you will get 211.45 Newton meter. Then speed of the screw is nothing but speed of the nut divided by pitch of the screw. That is, speed of the nut is 300 divided by pitch is 6. Then 50 RPM you will get. Angular speed 2 pi n by 60. So it is given as, what are the values that is given, we are utilizing that one. So it is 2 pi 50 by 60, that is 5.24. So kindly go through the formulas. In this type of problem, you have to study the formulas. Without knowing the formulas, it's very difficult to solve the problems. So very important steps. Then angular speed, omega equal to, that we have discussed, power T omega, that is 211.45 into 5.24. Just multiply that two values, finally you will get 1.108 kilowatt. Then again, this problem is same, related to the same type of the problem what I discussed in the previous one. Same problem, same method. So now we have this problem, we have the data of D is given 50 mm, P equal to 12.5 mm, mu equal to 0.13, and load is given as 25 kilonewton converted to Newton. Then tan alpha equal to P by pi D. We are using this formula and get the value of 0.08. Force required on the screw to raise the load, that is P equal to W tan alpha plus pi plus equal to W into tan pi minus tan alpha 1 plus tan pi tan alpha. Finally, you will get 5305 Newton. Then you are using torque required on the screw is nothing but P into D by 2. Upon calculation, you will get 132625 Newton mm. Then ratio of the torque required to raise and lower the load. This formula, this again, the raise means you have to use positive, lower means you have to use minus. The top we have used plus, here it is used, we are using minus. Then the pi will come before. Helix angle will have the less angle, therefore it is minus alpha. Then torque required to lower the load, that is T2 equal to P into D by 2. Then 30,905 Newton mm. Ratio of the torque required T1 by T2. You will be getting 4.3. Overhauling and self-locking screw. This is one condition we are using, self-locking. Whenever a screw jack or whatever it may be, lifting the screw, it should not come back. Because of that less friction, it should not get come back. That is a condition we are using. That is T equal to W tan pi minus alpha D by 2. So this is the condition. If pi is less than alpha, then torque required to lower the load will be negative. Same thing we have utilized in the problem also, where you are putting minus. So the load will start moving downward without the application of any torque. So that's the main case. Without any load, it will automatically come down. Such a condition is overhauling of screw. If however pi is greater than alpha, the torque required to lower the load will be positive, indicating effort is applied to lower the load. That will be called a self-locking screw. So again, based on the problem, self-locking of the screw, the same using the concept, we have solved one problem on that self-locking screw. The load of 10 kilonewton is raised by means of the screw jack having a screw thread screw of 12 mm pitch and mean diameter 50 mm. If the force of 100 Newton is applied at the end of the lever to raise the load, what should be the length of the lever used? Take the coefficient of friction as 0.15. What is the mechanical advantage of obtained state whether screw is self-locking? It is asked whether self-locking or not. So again, tan alpha formula we are using. Effort required is the circumference of the pitch and the screw to raise the load means positive. We have used positive formula. Alpha plus phi. Then T equal to P into D by 2. That is the torque required to overcome friction. Then how is the torque applied at the end of the lever? That is P1 into L. How much effort we are giving. That is the formula we are utilizing. Then finally you are getting L equal to 572.5. Then mechanical advantage is nothing but a load applied divided by P1. That is 10 into 10 to the power 3 divided by 100. That is P1 is given. You will get 100 only. No unit for that. Self-locking of a screw efficiency is given by tan alpha by tan alpha plus 5. Upon calculation, we will get 33.35 percentage. So this is the reference which I have took for preparing this content. Thank you students for your kind attention for listening this video. Today we have covered the important introduction part of the friction. In upcoming classes, we will solve the problems based on the friction. Kindly subscribe the channel and share the video to your friends. Thank you.